Let's say you lost midway through a journey while trying to find your friend's place. You show the address of your friend's house to someone passing by. What will you ask the person? Will you ask, "Can you tell me the distance to this place?" Or will you ask, "Can you tell me the direction to this place?"
Obviously, the latter one, right? Only knowing how far your friend's house will not help you reach there. Of course, you do need to know how much distance to travel, but you also need to know in which direction you have to travel. So what we see here is that in order to describe a location, direction plays an important role. Usually, we describe a quantity by just mentioning its magnitude, that is, its amount or size.
For example, the mass of an object is given a numerical value. The size of an object, that is its area of volume, can be described just by a number. Similarly, speed, distance, temperature, etc. are quantities which can be completely described just by a numerical value. Such quantities are called scalar quantities, a quantity which does not depend on direction. Sometimes, to completely describe a quantity, we need to specify its direction to along with its magnitude.
Let's say you wanted to throw a ball to a friend. For this, you not only have to decide how hard you throw the ball, but also in which direction you have to throw it. That is, how much force to apply and in which direction. Another example is wind. To describe the wind flowing at the place, we need to specify its speed and the direction in which it's flowing. The speed of an object and the direction it's moving in is called its velocity. Such quantities, which are completely described by its magnitude and direction, are vector quantities. In mathematics and physics, you'll encounter many vector quantities like this.
More examples of vector quantities are displacement, acceleration, momentum, and so on. But today, we will understand some basic concepts about vectors, various operations on vectors, and their algebraic and geometric properties of vectors. Mathematically, a quantity that has a magnitude as well as direction is called vectors. Let's consider one abstract example of it.
Let me ask this. Is a line segment a vector? No, right? The line segment only has magnitude, and that is length, but no direction. Now, let's see we specify a direction for this line segment via arrowhead. This means that the line segment is now directed from A to B. So let's call it a directed line segment. So now, we have a magnitude and a direction for this directed line segment. Therefore, we can say that the directed line segment is a vector. We denote it as this. It's called vector AB. The arrow above the letters tells us they represent a vector. The point A from the vector AB start is called an initial point. And the point B where it ends is called the terminal point. The distance between the initial and the terminal point of a vector is called a magnitude, or the length of a vector. It's denoted as this, and the arrowhead indicates the direction of the vector. We know that, for a line segment, we can show the direction in two ways. So here, instead of this, if we join arrowhead like this, then we can say that the line segment is directed for B to A. And thus, we get another vector BA whose initial point is B, and the terminal point is A. It has the same magnitude as vector AB, but is directed in the opposite direction. Usually, to denote a vector, we also use one monotation instead of these. We can denote a vector by a lowercase letter with an arrow above it. So this is the vector A with the magnitude denoted as this. Then this is vector B with magnitude denoted as this. Thus we see that a directed line segment, which is a simple mathematical entity, is a vector. Now, to represent any vector quantity, we have to state its magnitude and its direction. Hence, to represent geometrically, they usually use a directed line segment. For example, let's say that we have to represent the velocity of the car at these two places. Then we represent it like this, by vectors velocity 1 and velocity 2. Now, we know that the length of the line segment represents the magnitude of the vectors. So, as the speed here is twice than that here, we represent the length of this vector as twice the length than it's here. Thus, we can see that if we have a vector quantity d, we can represent it by a directed line segment. That is, an arrow like this. Its length represents the magnitude of the vectors and the arrowhead is its direction.
When measuring the magnitude in an object, we must identify and include the direction in which it is applied. It is always important to remember that the direction of an object will always determine where we want it to move.